With the rapid advancement of 3D printing technology, part manufacturing is being changed in ways that make all new products possible. CAD software now integrates 3D printing tools directly in the user interface and leverages functionality such as generative design to create optimized geometry that fits the exact needs of the part. Online communities and file-sharing platforms are also making models available to anyone, which can serve as a part to print directly or use as a base model and make adaptations. These tools and platforms are also being applied to materials and applications other than 3D printed plastic parts. Metal parts are now able to be printed, which simplifies the manufacturing process and keeps material from being wasted. In addition, other non-mechanical materials can be printed as well, such as implantable biomaterials and particular food types. The world of 3D printing is going to continue to expand quicker than we may realize, bringing a lot of excitement to what the future holds. Most CAD titles now include a number of 3D printing tools integrated directly into the user interface. SolidWorks has partnered with machining and software vendors to allow you to set up and create sliced parts directly inside the software. This allows you to quickly iterate designs without the need to deal with time-consuming and hard-to-track exported files. You can also see where a part needs supports added based on the orientation. In addition, you'll be able to see if the part will fit into your machine's build space. Tools such as 3D Expert for SolidWorks from 3D Systems can also automate processes such as combining an assembly file into one single printable part. Slicer software isn't the only technology being implemented directly into CAD. Generative design tools, such as Design Guidance within XDesign, are helping designers create more complex but stronger parts that may not be able to be machined but can easily be printed. This allows designers to potentially use less material while gaining structural strength. And because 3D printing can orient the part and print it in various shapes and sizes, the designer doesn't have to be overly concerned with manufacturability. The resulting shapes tend to also have a more organic look to them, as opposed to the traditional mechanical look, which can always be refined if needed. One great way to begin working on a design is to see if there are existing 3D models that you can adapt and work from. There are some great online resources that make models available for download and direct printing, or bringing into a modeling software and making modifications. SolidWorks hosts the 3D Content Central, where users in the 3D Experience community can upload their designs and share them with one another. These can be downloaded in a variety of formats, such as the SolidWorks part and assembly files, or even an STL generated directly from the website. This is a great place to find models you're looking for, since the native CAD file type is one of the available download options. Many other websites that host community-shared models only make STLs or graphics files available, which are much more difficult to make edits. The website Thingiverse is also a great resource with tons of models available for download and printing. Depending on the member that uploaded the file, they may have also posted the native CAD files for download. It simply depends on which files that user chose to upload. In the next video, I'll discuss some of the ways in which 3D printing is advancing and what other materials and applications are being leveraged. As 3D printing continues to be adopted by companies and individuals, new technologies are becoming mainstream. 3D printing isn't restricted to just plastics, but has made its way into the world of printing metal. Metal printers from companies like Desktop Metal and Markforged are allowing companies to print final design parts at the lowest costs possible. With these machines, different types of metal materials can be printed, but all will require some sort of post-printing curing to fully harden the part. The ease of use of the machines, along with the easy-to-use software programs, are allowing for this technology to gain momentum at a very fast pace. Another emerging technology is the SLS printing process. This stands for selective laser sintering. It falls in between the costs and complexity of SLA and metal printing. It's similar to the SLA printers in that it uses a laser to harden material. However, it's solidifying a powder instead of a liquid resin. One of the largest benefits of SLS printing is the ability to print multiple parts that are interconnected by support material that can be easily broken away. Formlabs also makes an SLS printer that provides a low-cost entry point combined with a user-friendly interface. This makes it easy to get up and running making professional-grade parts. Regarding emerging applications of 3D printing, the medical field, cooking, and space travel are all benefiting from this advancing technology. In the medical field, there are many emerging materials also in development that are allowing for printed parts to be placed inside a human body without the risk of causing infections or the body rejecting the part. Experimental materials such as skin cells and body organs are allowing for further exploration into printing human body parts. Regarding cooking and food preparation, 3D printing allows for food to be stored in sealed hygienic containers and then printed out when ready to be consumed. This can be extremely helpful when needing to transport food to impoverished countries without worrying about how the food will last as it's transported. And finally, in the use of space travel, the use of 3D printers is allowing tools and parts to be readily manufactured without the need for waiting for costly resupply missions, which can also take months to occur. This allows the astronauts flexibility in what they need, and the preparation time and materials can be reduced prior to conducting a successful launch. With 3D printing technology taking rapid steps forward, the future holds great potential for manufacturing and how efficiently new products can be created.